Hello, so today we are going to do this Leetcode problem, part of Leetcode April challenge. So it's search in binary search tree. And the problem says we get a root of a binary search tree and an integer value, and we want to find the node that has that value and return the subtree rooted with that node. And if we don't find it, we can return null. And one thing to note about a BST is just a tree where the left element is always smaller than the node, and its right child is always bigger than it. So left child always smaller than the node, than its parent, and right child always bigger than the node. So that's kind of the property of binary search tree. So we can take advantage of that and solve the problem. I'll solve it first with the recursive solution, and then from there do an iterative solution. Okay, so the first thing we can do for the recursive solution is we know that if the node is null, which in Python we can check with this, we're going to return nothing, right? Because there is nothing there. Now we can compare. If the value I'll just make this be node to make it easier to read. Now if the value is equal to the value we are looking for, then we need to return that node, right? That's what the problem asks us to do. Now if the value is smaller than the node value, that means we need to go left, and so we can return, but we need to recursively search on the left side. We know it's smaller, so it has to be on the left side. And so we look for search BST for node.left. Because it's smaller, it has to be on the left side. If it's else, which means it's bigger, then we need to search on the right side. And that's pretty much it. So let's run this. Okay, so we are missing, yeah, we need to pass value as well. And that passes test cases. Now, to do the iterative solution, instead of doing a recursive solution here, we can just put this back to root. Let's make this be the root initially, and then we will keep going until we reach a null pointer, until we exhaust the tree, right? And now we check if the current value is equal to the value, then we found it, so we return current. Otherwise, if the value is smaller, which means we need to look left, and looking left just means that in the next iteration current is going to be current.left. This is the same thing that the recursive function did. In the else case, we know we want to look on the right side, and so we need to assign to current.right. And at the end we want to return current. This is because when we exit the while loop, current will be none, and so we need to return it because that will mean we couldn't find any node that has the value val, essentially. And yeah, that's pretty much it. So let's run this version. Let's submit it. Yeah, and that passes test cases as well. Yeah, so this is a pretty straightforward, easy problem today. Thanks for watching, and see you on the next one. Bye.